Hello and welcome to Unapologetically Technical. My name is Jesse Anderson, and this is the show that's different. We go deep. We go all the way down. With me today is Arvind Prabhakar. He is the co-founder and CEO at Tabsdata. Welcome to the show, Arvind. Would you mind telling us a little bit more about yourself?
Thank you, Jesse. Very glad to be here. My name is Arvind Prabhakar. I'm based here in San Francisco Bay Area, currently, part of the two founders that are bringing Tabsdata to life. Prior to this, I was the founder of a company called StreamSets, and I've been in the software technology space for the last 27 or more years. I did my schooling in India. I was born and brought up in India. I did my schooling and my undergrad studies there. I did a part-time graduate degree here in the United States. And at this point in time, I've spent more of my, living time here in the US than anywhere else in the world. So very much kind of deeply rooted here in the Bay Area. But happy to go into any of those aspects or anything else that you like, Jesse.
Sure. So you didn't mention it specifically, but you were an IIT, Indian Institute of Technology graduate. We've had a few people from IIT on the show, so always good to have that. Now I know to look for IIT, and I understand the level that puts someone to when they're at that. You also mentioned, you talked about spending most of your life in the US, but one of your bucket list items that you wanted to do was to go to Goa. Tell me more about that.
Yeah, so one of my very, I would say, closest friends is from Goa. When growing up, we would see Goa in movies. It's one of those places where it's kind of like the Switzerland equivalent for India, and would hear great things about the weather, the people, just the overall layout and the way the whole uh, social structures are over there, because there are different mixes of different cultures. That's the case with most cities in India. Panji, for example, the capital of Goa, is well known for the temples and the churches and so on and so forth, and the beaches, of course, and the food, and something called feni, which is a local alcohol that they make out of cashews, because there's huge cashew plantation. But anyway, this was something, one of those really cherished kind of memories, seeing Goa in the movies and such. So finally, when I was in college doing my undergrad, I had an opportunity to go to Goa, and I loved every moment of it. I was, of course, staying with my friend's family, who were really extremely nice hosts, and they not only took care of me but also showed me around, and that definitely had a lasting mark, to the point where my wife and I, we've often talked about, hey, when we have a little bit of a breather in our careers, we'll go back and spend some time there and just soak it in. It's a beautiful place. Just tell you how remarkable Goa is. And I think this may be because of the historical aspect of Goa being under the Portuguese for some period of time. Uh, there are sidewalks, which is not normally the case in most planned cities in India. Maybe now that has changed, but growing up, I didn't quite really notice that. There were almost every short distance, there would be a 24-hour pharmacy, which is, again, not something that was there in other parts of India. So there's a progressive aspect to Goa that is fantastic. The people are sweet, and the place is just breathtakingly beautiful.
Yeah, you pointed out the reason that we originally started talking about it we were talking right before we started the show. Since I live in Portugal, I didn't know that Portugal had so many colonies. I knew that Brazil, for example, but I didn't realize all the way in Goa was one of the colonies. I just did not know that. And then to hear how beautiful it is, and then to talk to some of the people who live there, I was also surprised how good the Indian food here is. So, uh, And then I was watching a show about Goa, and they said the word for bread, which is the same word as in Portuguese, pão.
Yeah.
And it surprised me that they were using some of the Portuguese words too.
Yeah, yeah. There's a lot of overlay of different cultures. I think India has uh, every 100 miles you run into a different language, a different way of dressing, a different cuisine, different cultural aspects. But then you step back, or if you're immersed in that environment, you can actually slowly start to become aware that there are so many of these overlapping appropriations of the lack of a better way of expressing it, words, meanings, things that have come together through the mixing of people from all over the world. But yeah, that strong Portuguese influence in Goa.
Good. Well, you getting more technical, you in over your long career have done a lot with the Apache Foundation. And what I've seen is I think there's still enough, or there's still as vibrant a community around open source. But what I think is different is that they're not being homed in the Apache Foundation like they were much earlier on. They're not even being homed anywhere. They're not in the Cloud Native Foundation. They're not in the Linux Foundation. They're not in Apache. They're just open source from the company. What's your view on this?
That's a very interesting question, very very telling of the times we're in right now, Jesse, because um, I've dabbled with open source from way back when Java.net was an open source initiative by Sun Microsystems in the early 2000s. Um, and through the course of it, I've interacted with different consortiums, foundations, and so on and so forth. And I have a lot of opinions about what works, what doesn't work, and such. But regardless of my opinions, I think the top level idea around open source is two-faceted. It's two-dimensional. The first dimension is what is the license? How are you giving away? What exactly does it mean to be open source? And if you take a point in time for any particular technology that is open source, you end up going into that open source technology from the perspective of some kind of a benefit to the community, to the user, to the developer, to the adopter, and so on and so forth. So the license is what controls that. Apache license, especially the Apache license version 2.0, that was adopted way back when, is the most prolific, I would say, is the most relaxed license that exists out there, which allows you not only full access to the IP that may be buried in that technology, but also you can utilize it for any purposes, commercial or non. Um, and the way that license works is that the purity or the value of the license only gets translated if the entire software is developed with a mechanism by which when you adopt a technology that is Apache license, you get the rights to the IP. You can use it for pretty much any purposes that you want. That's the beauty of the Apache license, especially the Apache license 2.0. The second dimension of open source is governance. How are you going to run that project? And the governance piece is actually very telling because it allows you the knobs and dials to make sure that the technology takes shape in a manner that the owners or the people who started it or the people who are deeply vested in it have imagined or where they would want to take it forward. So Apache Software Foundation is something that uses the Apache Software Foundation's governance model, which I think can be summarized in one sentence, their motto, which is community over code. They can make sure that they are enabling the community to contribute and not necessarily doing it for the purposes of code being the most important, the most useful. Their belief is a thriving community will produce the best products. And there is a lot of truth in that. it takes its own course. It takes a while. The Apache web server, which basically started it all, is a prime example of how that could be done. And the fact of the matter is, there are thriving Apache Software Foundation projects, that have deep impact across the board. Now, having said that, that comes together naturally when the stars align, when the different stakeholders that are there in the environment, they all have this meaningful overlap that they could benefit from that governance model. But that's not necessarily the case always. And what we saw in the 2010s was like this strong kind of attached to that governance model to benefit a go-to-market strategy that a lot of the different technology vendors were trying to execute on. And that helped. That definitely helped move the needle forward. But over the course of what followed with the technology explosion, with cloud adoption and such, it became very clear that governance model did expose, or did have some vulnerabilities that could affect the people who were deeply investing in these technologies in a way that they could not handle. So that eventually gave rise to what I believe is like the modern patchwork of open source, which is, yes, there are Apache Software Foundation projects that are there, not quite happening the same rate as they used to, but they're still there and they will continue to be there. There's these other foundations, Linux Foundation, Cloud Native Foundation, the Kubernetes sort of project umbrellas. All of these things are trying to help project owners, people who are bringing these technologies to the forefront, have the necessary tools to be able to run the project by themselves. And then there is also a growing cohort of technology companies, such as Tabsdata, for example, such as StreamSets too, for a little extent, that have decided to hold on to the governance. They want to govern the project by themselves. They want to have the final authority on what makes it in, what doesn't make it in, how does the IP handling work, and so on and so forth. So it's as is the case with any new approach, it definitely shot off through Apache Software Foundation, and thanks to the ASF, it brought that to the forefront of the enterprises and the people using these technologies. But then, of course, with time, the needs were becoming more specific, and all the vulnerabilities started showing up in the way of different sort of implementations, and hence we have the checkered mix of all the different types of governance that we use today. And of course, there's a similar argument to be made around the licenses too. There are other open source licenses, not just Apache License 2.0, which cater to specific needs that the vendors have, that the users have, that the contributors have.
Yeah, it's interesting to since we both worked at Cloudera, and that's kind of that intermingling here of that early time. It's weird how open source and business model intertwined at that time so much. And then I would say the next generation of those companies, their next generation was, let me make something where we run our own cloud, and our own cloud is where we monetize. Where at Cloudera, it was, let's have some sort of Cloudera manager or some sort of thing that does the enterprisey things, and that's what you pay for, but everything else is open source. Even CDH, the Cloudera distribution, was open source as well, where now we're seeing much more, for example, with Databricks, here's our Databricks cloud, that's where we make money. It's been interesting to see that pivot in how the business models were.
Yeah, absolutely. And some of it is intuitive, that kind of follows a natural trajectory of vendors trying to go into the market, create their niche offering, and create their value proposition. Some of it is counterintuitive at times. Google's open source strategy has always had me head scratching as to what exactly is their motivation. Are they doing it for the community? Are they doing it for the brand? Are they doing it for themselves? And every time I feel like, oh, I think I understand and I can put a finger on it, they change it. So it's crazy. Like you can't ever predict what's going to happen. It's because it's free, quote unquote, and well, I don't believe anything is free, but um, at least on paper, it is free. It gives a lot of leverage and authority to people who are driving that governance model and the license and such. So, and sometimes they don't have well thought out strategies. Sometimes they just kind of bump into walls and then change their strategies, and that's okay. That's just the nature of the way we grow as humans.
It definitely is. So, speaking of your growth, let's talk more about the companies you started at. Your first job was a software engineer at a company called InfoQuest Infotech, and you were working on an RMI registry. I assume that that was a remote method invocation registry.
Yes, yes.
Well, start off with tell everybody what an RMI is, and then why would you even need a registry for that?
Oh my God, this brings me back, and I probably will, you know, I'll give you the best answer from my recollection. It's been such a long, long time, but RMI, remote method invocation, as you mentioned, it was a way of implementing distributed systems on top of Java platform. And I think at that point in time, I started working with Java when it was point 0.9, and that was in 1995 or 96. I forget when exactly, but it was point 0.9. It was not 1.0. I think the 1.0 came out, gosh, it's hazy, but somewhere around that time, 1.0 came out, and 1.0 had the early versions of the RMI implementation, the remote method invocation implementation. And prior to that, there were these, the common object resource broker, the COM in Microsoft Windows, bridges for doing remote invocations. And RMI actually simplified. In retrospect, it was actually very simple as compared to some of those other technologies. And I used to, I'm completely going to date myself, but I would look around and see cars driving the road with I unknown as license plate, and I'm like, oh my God, I get it. And very few people would get, but this people who were into infrastructure and distributed systems, they had a handful of technologies that would enable what they like. RMI was fantastic because RMI simplified and made it accessible to, I would say, a young average developer who was me, to be able to actually do something meaningful. Now, to the course of that experience that I had in InfoQuest, I actually worked with lots of different clients, primarily for like very short consulting engagements. But then the RMI part was actually a long project. That's why I wrote it there. And that was me working with one distinguished engineer in Sun Microsystems. So I was subcontracting to Sun. And there was this gentleman who was fantastic. He was, for me, he was someone who espoused pretty much every aspect of like the personality and the character that I aspired to be, because he was brilliant and he knew his way around extremely complex systems, and he had that sense of clarity, and you could just go to the whiteboard and just hash out like a design and tell you exactly what are the compromises of that design and why it makes sense. And I learned a great deal working with him. The project that he was doing was implementing a network management system, which was effectively, just a side note, Sun used to sell a lot of hardware, and the goal of the software stack was to enable the sale of the hardware. I don't know, in retrospect, that was the right thing or wrong thing, but it was what it was. And what we were doing, we were a 3% team, the distinguished engineer, myself, and then there was one consultant that would come in and go occasionally. But what we were building was a way to remotely monitor server logs, and make sure that we attach into the specific machines and go into the details of like, what's working, what's not working, etc. just by reviewing the logs and pinpointing into the specific problems that maybe run, be able to issue remote commands to do, activity monitoring like top outputs and so on and so forth. And, the RMI registry was part of the Java platform. It was in really early, kind of like a few rough edges here and there, but was fantastic innovation. Later that year, or maybe next year, I forget when, Java standardized on the JNDI service, which is the naming and directory interface. RMI became one of the first implementations of JNDI. JNDI it was basically naming and discovery for network components that could give you address transparency. So all the distributed system nerds will remember the transparencies that we would talk about every now and then. We take it for granted now because like pretty much every software system enables that by default. That was not the case back in the 90s. So address transparency is when you want to access a network service, but you don't really know where exactly it's hosted. So there's a service, naming and directory interface that'll allow you to go discover it. In the meantime, there were parallel initiatives by, I believe, Microsoft, and at that point in time, Ariba, maybe IBM, UDDI, the Universal Discovery Interface something, Description Discovery Interface. That was also like, one of those kind of competing ideas that would enable, but the purpose of all of these systems was to allow you to build remotely accessible distributed systems, that can give you the power at your fingertips to do meaningful things. Did I skew away from the original question of what RMI registry?
No, I'll just briefly explain what RMI is, in case people don't know. You're completely right. It was actually beautiful because very transparently in Java, you could call a method on a completely different server and not really have to worry that it was on a different server. And that for that time, that was pretty interesting because you would get an object back. You would get a Java object back. And other ones, Corba implementations you were talking about, you would get some strings back. JSON, you would get some strings back and then have to do that. But you were actually transferring, you were serializing and deserializing Java objects around in that interface. And then the RMI was the way to figure out, okay, I'm going to call this thing. Where is that other computer? And so all interesting things from back in the day, and it worked well. In some ways, the reason I like to ask some of these early on questions is that we come full circle, and until you have an experience, you may not understand you're coming on a full circle, because we went from very definite things to, okay, now we'll just kind of throw it out there and we'll use like a UDP sort of discovery to throw it out there and see who, or even Kafka being kind of a similar thing of let's throw a message out there and see who does whatever with it.
Yeah.
I mean, very interesting. So from there, you went to principal software engineer at Netscape, and Netscape, for those who don't know, that was the hot company when you went there, and you went there as a principal software engineer. How did you get such a high title so fast?
So, so that part of the journey is wild. It's I would say it can only be described as, I'm not saying this to get any credits, but Silicon Valley things, because it's so wild that normally when I tell this to my friends and colleagues and relatives, they're like, this guy's smoking something. But anyway, let me tell you, like, give you a summary of what happened. So I was subcontracting through this company that you know had me work with Sun Microsystems for that first, the RMI, the network management project. And then my second major project was with Netscape. And it was actually not with Netscape, it was with a small team which came from a company called Kiva. Kiva was an application server. There used to be two application servers in the market at that time, Kiva and Netdynamics. Kiva was considered the application server for the large enterprises. And Netdynamics was the application server used by maybe mid-market or small, excuse me, small sort of smaller shops, not large enterprises. And both of these application servers were fantastic. They had a lot going on, in terms of the ability and such. So I was fortunate enough. I naturally liked server infrastructure. That was my thing. And I got to work with, the Kiva application server. Now, through the course of that project, Kiva was in the process, or it was already acquired. I don't know exactly. I used to be just heads down, focused on implementations. Wasn't paying that much attention, but Kiva got acquired by Netscape. So I got inherited as a contractor working for Kiva to Netscape. Now, Netscape wanted to hire me. And because I was a contractor, they had some, I guess, fine print agreements with the contracting firm and so on and so forth. So they had to go to the right channel, and that wasn't working out. And I had no idea that Netscape was trying to hire me. And I, at some point in time, figured, like, you know what, my roots are in product development. I need to go towards product development. So I'm going to go look for a job. So, and I got a job offer from another company, which, was also a very nice company. And I told, my Netscape manager, saying, hey, this is great. We should plan on winding this down because I'm about to accept that offer. And that person, my manager said, like, how about Netscape offer? Why aren't you accepting Netscape? I'm like, I had no idea Netscape had an offer for me. So it turns out something was lost in translation. There was a communication issue, etc. But I figured, Netscape was very much, and my preference would be Netscape because it was the company that everybody, wanted to work at. So I'm like, yep, I'm jumping on it. And part of that was I could not change my role until my H1 got transferred. H1 was the work authorization, for, immigrant workers in the United States. That process took a long time. And that was part of it, was just the weight that, the backlog that the immigration agencies deal with on a routine basis. But also part of it was the fact that in the process, Netscape was getting acquired by AOL. So by the time my H1 transferred, like within weeks, Netscape became part of AOL. And that process took like a year or a year and a half or something, like some crazy amount of time. Once Netscape became part of AOL, this second phase of this wild ride started, which was that AOL purchased Netscape. Again, this is my opinion, may not be right. I don't know what the actual motivations were, but my understanding was Netscape only wanted the NetCenter website. NetCenter website was this one website Netscape used to run where all the Netscape browsers would go as a homepage. They had tremendous traffic. So AOL just wanted that. They didn't want anything else. And Netscape had a very thriving server business. They had a whole bunch of servers, and they had acquired, the Kiva application server. They called it the Netscape application server, from that point on. They had a directory server, which was like fantastic. It had way more deployments than, the Active Directory from Microsoft. And they had a few other things going on. They had the certificate server. So thriving, 70%, in my opinion, business of Netscape was, or the people were basically working on the server infrastructure. And so then, since AOL did not want any of that, because AOL had no enterprise software development bone in their body, they wanted to get rid of it. And in California, which is where Netscape was based, you cannot buy a company and get rid of more than 50% of it without incurring severe tax penalties. So AOL did, what any smart company would do. They forged an alliance with Sun Microsystems, where they gave the entire server division of Netscape to Sun Microsystems. And all of us were reporting to Sun management, but our paychecks were coming from AOL. And this arrangement was for 3 years. And in those 3 years, every quarter, Sun would pay $100 million check or something like that to AOL in return for the rights to all the software and the ability to run that business for themselves. This was called the iPlanet Alliance. And it was a Sun Netscape Alliance. That's how it was branded. It was the weirdest thing. And not only there were a lot of confusion around like, hey, how what's my path of growth? Like, what do I do? Like, at some point in time, you're an AOL employee, you're not a Sun employee. And then, I was there through the ride of this entire alliance. And when that alliance started, something else happened, which was even more bizarre. Sun had acquired the other application server in the market called Netdynamics. So my first job was to go in front of the Netdynamics people who hated the Kiva people because, of course, severe competition, to train them on Netscape application server, which is Kiva. And I cannot tell you, Jesse, there was like this room full of like 30, 40 people who were so rowdy, and they hated my guts to go in front of them because Sun had decided to kill Netdynamics in place of Kiva, and they were all really, really upset. And of course, I was the target of their being upset, which is fine. Nobody was personally mean to me. They were generally rude. Like there was this one guy, like 40 years or more, I guess, like standing on the bench, and jumping, saying, "This is ridiculous. I don't even know how this application server exists. This should be like taken down." There were things like this happening in that classroom. It was fantastic. When you go to these experiences, it shapes you for life. So now I don't get fazed by any heckling. That those early experiences of kind of working with that team helped me. They're great people, but because of this, what some would describe as gross mismanagement of two really great technologies, a lot of the Kiva people left. And a lot of the Netdynamics people didn't have anything better to do because Sun had decided to, shut down that technology. So what they did was they took that talent pool of Netdynamics people and created a new project called the Market Maker, which was, at that point in time, there was a lot of B2B kind of craze, hype that was going on in the market. So this was a B2B marketplace, which would enable businesses to do lots of things with other businesses and such. It was primarily the Netdynamics folks, like I'd say 60, 70% Netdynamics folks. I got into that team. So, I made really good friends with, folks on the other side of the aisle, so to speak, competing technology. And it was a very, very fun ride. Learned a lot in terms of building enterprise software. Again, I was doing, in the weeds of like server infrastructure, doing backend programming for order management and external services systems and so on and so forth. Oh, and then, just the way the story ends, it's like 3 years go by in this process. And then, the contract got done because, California doesn't care after 3 years of what you do with the company. So we all got pulled into a room and got laid off on the spot. Some of us were lucky. As we were walking out, we got rehired by Sun because we were continuing the same job. But then by that time, the B2B craze had gone and there was a dot-com burst. Economy wasn't doing that well. And as a result, I got slotted into, because, I was pretty much on the server infrastructure, I got slotted into a security server that later became OpenSSO and Access Manager.
That's an interesting path, because you're talking about a span of probably 7 years where you went from job to job just by
Not a single
Arvind. Not a single interview, just which is good. I guess that's what's changed. You just have that dynamic personality and hard work, I guess. So you were there at Sun Microsystems, and you started working on the JEE containers. What were those? Why were those so important?
Yeah. So the specific initiative that Sun was driving at that point was security infrastructure for the enterprise. And just to give you some kind of a color on why this was relevant, this was the time when Sun was actually pushing for large scale deployments, hardware deployments for running all these enterprise shops. Like E-Trade, for example, was a very big customer for Sun Microsystems and such. So Java Enterprise Edition at that point in time, it used to be called J2EE because it was Java version 2. Enterprise Edition had a lot going on in terms of enterprise scale out, large scale application building and deployment features. And one of the things that was not quite up to the enterprise standards was security in these systems. So Sun started this initiative, which was an offshoot of the directory server, and it was called DSAME. It was the weirdest name, DSAME, which is Directory Server Access Management Edition. And I was part of that initiative that later changed its name to Access Manager and OpenSSO. Part of it became open source and became OpenSSO. My goal, the reason I was brought into this project was because most of the implementation was broken into like three big pieces. So one piece was the policy agent, the policy infrastructure. So where you can have declarative policies, and those policies will have some kind of a deterministic compute, and collapsing on top of each other to be able to determine whether the outcome of a policy evaluation is yes or no, whether you should be given access to a certain resource or not. The second was infrastructure for natively compiled components. And the natively compiled components, the most important component there was basically the Apache web server. That was the widely deployed system. And also as well as the Netscape web server, which was now part of Sun Microsystems because, thanks to iPlanet Alliance. So there were natively compiled components, there were policy agents for those systems. And then there was this huge initiative from the Java EE side for having containers as the way to build and deploy and manage large-scale applications. So I was part of the Java part of it. And that was fantastic because at that point in time, Sun used to follow this a process called the Java Specification Request process, the JSR process, where different aspects of the Java infrastructure were determined by the community by rigorous processes, as well as input that was solicited from like a lot of different players within the industry. That was a good, reasonable, respectable process. So through that process, I was able to work with the folks that were building the JEE, the J2EE reference architectures. It was called a Glassfish server at that point in time. The idea really was to be able to tie into what they would call the realm, the security realm that was underneath, and then be able to externalize that realm and have a different security mechanism be able to work with it. So it was fascinating kind of experience for me because it just opened up the level of complexity that the Java Enterprise Edition was dealing with, and also at the end of the day, how powerful it was to be able to deploy your web applications, your enterprise applications, and such, and then have that seamlessly just be bound to your production configuration, and then work with your directory server for authentication and policy enforcement and such. So yeah, it was a big swath of initiative that Sun was trying to push, and I had the privilege of driving that aspect.
Well, that's interesting. It was a trip down memory lane. I haven't thought about Glassfish in so long, and everything that brought back was tons and tons of XML configuration.
Yeah.
Nothing but XML configuration. Just boom. That was so much.
Yeah. Yeah.
Well, from Sun, you went to Informatica, and you were doing very similar things. You were doing metadata repository management. Why did you? Why do you keep doing that theme in your career?
So actually, to me, in retrospect, that marks my shift in career, actually. So while I was at Sun, my core motivation was basically I want to do anything and everything with server infrastructure. I want to learn how to do massively scalable distributed servers. How can I leverage sort of the last compute juice from the hardware that we're operating on. How can I optimize for disk writes and so on and so forth, right? Not quite in the same sense as a database, but in general, concurrent, high concurrency server infrastructure. That was what my passion was. But then right around 2005, 2006, I had this kind of a midlife crisis of sorts where I'm like, what am I doing with my life? Where does this server infrastructure lead me to? It's kind of like I want to build engines. If you were to say I want to build engines, at some point in time, you have to figure out how do you specialize. Are you building aircraft engines? Are you building, boat engines? Are you building automobile engines? What are you building? Because engines mean everything and nothing at the same time. So server infrastructure is kind of the same, which is like, yeah, sure, I know a bunch of tricks and I've gained some good experience, but where is it headed? What do I want to focus on? And I decided I want to focus on data. And that came, with a lot of like internal soul searching and also like speaking with friends and mentors and people that I looked up to. And I realized that, having that focus was something that could give me not just the ability to sharpen my skills, but also be able to contribute a lot more, purposefully in that space. So looking around, Informatica was actually doing amazingly well, and it was doing something that was not quite the traditional database thing. That there've always been many database companies, and that still remains an area of active research and growth and implementation challenges that people are working with. But at the same time, it's also a little kind of like I'm sure a lot of people are going to get offended by what I'm about to say, but I think it's very, very conceptually kind of well thought out, and is the area of research and development has kind of shrunk quite a bit in terms of what you can do. Yes, sure, there's like consensus protocols for distributed systems that can then be applied to databases for multi-phase transactions and so on and so forth. But again, outside of those things, there's like not much going on. At least not in my untrained eye. I couldn't find much motivation in just going in the database, because that would have been, one fascinating area to go into as well. But what Informatica was doing was not doing databases. It was doing actually data integration. And data integration was not well sort of conversed or well regarded or well thought through thing at that point in time, mid 2000s. Because literally, like, had someone in Informatica explained this to me, saying data integration is something, it's a category where anything that you are doing outside of a database falls into. I'm like, okay. In those days, there were no like big data systems and so on and so forth. So this was kind of actually, more true than what it is today. But the fact of the matter is, data, when it is sitting in a system of record, is only accessible to that application that, through which that system of record is being maintained. But in a large enterprise, that data gets a lot more, gives you a lot more, bang for the buck if it actually gets integrated with other data, so that you can derive the insights, you can do your diagnostics and descriptive, but also like, forward-facing analytics on top of it, and so on and so forth. So I started to grok this a little bit, and Informatica was in the center of that movement of connecting data across different systems. I was lucky to get an opportunity to work there. In fact, at that point in time, Informatica was going through a complete rewrite of their platform, and I was part of that rewrite. And it was a very, very impactful learning experience. I got exposed to a whole bunch of customers, use cases, and what exactly matters to people, what are they trying to do, and so on and so forth. And that gave me this deep and inherent sort of appreciation for the complexity of data integration and why that is absolutely important in the modern times that we're living in for the enterprises to be truly data driven.
That is an interesting shift. I never really thought about what data integration is, being everything outside the database, but I'd have to agree at that time that would definitely be the definition. And so from Informatica, you went to Cloudera, and that was where we met up. You originally started there as a software engineer. What made you join Cloudera?
So prior to that, I had prior to me joining Cloudera, I'd become aware of Hadoop. And Hadoop was, I think there was a very highly cited New York Times article about deploying Hadoop for doing digitization of the slides and the films that New York Times had or some other media company had, and how that completely changed the game of like lowering the costs, as well as getting it done in a fraction of the time than what was projected by traditional consulting firms that would normally go for those kind of projects. So that caught my attention. I dove down a little bit deeper into that. I also became aware of some of the open source initiatives surrounding that ecosystem that were propping up, like things like Hive. There was a paper, by Facebook, I believe, around mapping SQL to MapReduce, and running that as MapReduce job on a Hadoop cluster and so on and so forth. So those are fascinating things. Right around that time, I had a friend who started working at Cloudera, and he reached out and said, "Hey, we're hiring, and you should really consider doing coming on board." So I went and talked with a handful of people there, and I was able to get an opportunity. Yeah. Uh,
And you joined at the first office, or not the well, there was the first office, and then there's the office by Fry's. You joined at that one, right?
I joined the Burlingame office. Yeah.
Oh, you were all the way back then.
Yeah.
Okay. Yeah, so that's the Cloudera lore of there was the first that first Burlingame office, and that was so you're pretty early on. Who was the friend that tried to get you on?
Carl Steinbach.
Oh, really? I haven't seen Carl in a very long time. I see him pop up every so often on LinkedIn.
Yeah. Yeah.
Okay.
He's doing he's doing well as what I trust. We haven't been in touch in a long while as well, but yeah.
Yeah, yeah. Well, since we're talking about Cloudera, one thing I've always been so fascinated by, or I guess so happy about, is here we are. We're 10 years on from our Cloudera careers, still having close ties with the people we worked with, and still fondly reminiscing about it. And I've asked Mike about that, Mike Olson, who is the CEO, and about what he did, how he did that, and it's a very unique company to have done that.
Yeah. 100% agree. I think Cloudera had a um, very strong culture. It changed over a period of time, of course, as the case with any company that goes through rapid growth. But in the early days, I think it was very rewarding and very engaging culture. Um, I used to work late, and Mike used to come in early. So there would be times when I'm still in the office and Mike shows up at like 3:30 a.m. in the morning. And it's like, "What are you doing?" I'm like, "What are you doing?" But he would, of course, try to beat the traffic coming from Berkeley, and also he would have meetings in APAC and other places in the world that he had to be on the time zone for.
I've never heard that story. I didn't know Mike was such a young, or I guess an early riser. I'd never known that.
You know?
Okay. And then, uh, and if people don't know, Mike would write this email. He would write this email to the company and he's doing it again. He's not doing it just to the company, but it's called Not a Tech Bro. But it was very interesting to hear his kind of uh, all sorts of not ramblings, but they were his views on various things, and I always thought that they were very well written. Uh, everybody that I know still has a great deal of respect for Mike, and we all miss him. So,
Sure.
but, but yeah, I don't think he's going to start another company. I think he's happily retired and sitting on boards.
Yeah.
So you started originally at Cloudera as a software engineer, but you got into management. Why did you go into management at that point?
So when I joined Cloudera, there were no managers. I mean, we all reported to Amar. Amar was the other co-founder at Cloudera.
Amr Al-Awadallah, CTO
Yes.
of Cloudera.
Yeah, who's now running Vectara. That also has like a good uh, set of ex-Clouderans at Vectara. But Amar was great, but he was not really a manager. He was just, he was more of a visionary kind of technical person. And the effect was that we were all basically self-managed, and we continued to operate in that. And one of the things that helped me quite a bit by not having active management kind of overseeing me was to get a good sense of what it takes to build something from scratch. How do you go about establishing a business? And it was almost like a front seat row in that show where we're kind of bringing something from nothing into the market and making it useful for enterprises, and having them give us feedback and course correcting accordingly, and so on and so forth. So it was a great exercise. Now, later, after a year and a half or so, things, really started picking up steam, and we started growing, and management stepped in. And at that point in time, I did have a manager early on, and I found myself, uh, and this may be like a one-off, but I found myself at odds in the way of thinking with how my manager was thinking, and there would always be this much friction. And at one point in time, I kind of went up to Amar, and he's like, okay, listen, I trust your judgment. Why don't you run that particular piece? So it was just that. And then my team that I had running those projects were way smarter than me. So it was not that I was managing or I was nurturing them. We were kind of working pretty much in the same mode that we were working before, but not quite at the entire company level, in that small group level. Um, Over a period of time, that organically grew into me being like a quote unquote, like a traditional engineering management person. Um, and that did, you know, uh, bring in challenges around actual growth of people and managing conflict and this, that, the other. That is, kind of the Kiva when you're dealing with large teams. Um, but that still was like not the primary kind of focus of my work. I was still coding, I was still working with my team, and I was still, having a lot of fun doing what I was doing. But it was just a natural shift in.
But one of the interesting things that you started managing was Hue and Sentry. And for those who don't know, Hue and Sentry was basically the Sentry specifically was the way that you did the authentication, security, and such. Hue was more of uh, it was a UI, a better UI for user interface for Hadoop. So shout out to Romain for his work on Hue. Hopefully he's doing well. But what I found interesting was that Sentry was really the battleground, because at that point in time there was no real differentiation, or there wasn't as much of a differentiation between the distributions, the Hadoop distributions. And so what they fought over was the Sentry. That I thought that was the real battleground. So what was your view on that, being the manager of the battleground?
Um, I, this is such a close to heart story. Um, let me be um, careful in how I share it, because I don't want to ruffle feathers anywhere. It's been long gone, but I started Sentry. It was, it's as a way to address a key business requirement, which was to do column level security on Hive. And I don't know if you followed Hive, but Hive was initially it was brought by Facebook, and Facebook, was doing a lot of work and like steering it and keeping it aligned with its needs and so on and so forth. And then over a period of time, it definitely had a lot of Hortonworks presence. Hortonworks was a key competitor at that time with Cloudera. Um, and Cloudera by itself was not as engaged in Hive contributions as it was, because it was building Impala, which was a sort of a much more different scale of like OLAP kind of implementation on top of HDFS. And so that said, a lot of the Cloudera customers were deploying Hive. And one of the things that was gating our land and expand was, the features in Hive, and the Hive community was extremely slow moving at that point in time, primarily because of the open source back and forth, and just the way of the governance, of the project, the way it was working. So the business need that I was trying to solve for was, how do we implement security for column level security, particularly for Hive? And by extension, this was the same requirement that we had coming in from Solar. Like, can I have certain index attributes in the documents, be secured from being read by certain people and so on and so forth. So there was this pattern of security implementation that was necessary across that ecosystem, not just in Hive, but in other components as well. And that was basically the key motivation for building Sentry. And we started it off as, on GitHub, on Cloudera GitHub, and then we brought it into Apache Incubator. And we were not only able to deliver the tight security and the policy. Now, a lot of people will say that this was done poorly and it was wrong, and it could have been this way, that way, the other. It was not best suited for X outcomes and so on and so forth. And there's a lot of truth in all of that. But you have to balance that with working across multiple open source projects that had their own destiny, and they were not seeing eye to eye. So Sentry was a way to sort of take a step back, in a decoupled way, but tightly integrated, that could give you the security and control. Eventually there was another project called Nox that came primarily from Hortonworks, and that also solved for the similar thing. But again, you have to realize that we didn't have the luxury of waiting for a year and a half, 2 years to be able to deliver those. So it was a need of the hour. I had a great team that was behind it, and we understood these systems really, really well to be able to implement this in a manner that would address that business need, and also keep these projects independently rolling in the directions that they wanted. So I felt that was a good compromise.
And so you eventually left Cloudera as a director of engineering, and you founded, or you co-founded, StreamSets. Why did you decide to found a company at that point?
So I think a lot of this is just, sort of organic evolution from my perspective, because what Cloudera backing up. When I joined Informatica, I was focusing on data, understanding, where exactly data is relevant. The data is relevant inside databases, outside databases. I chose the outside the databases world. And joining Cloudera gave me a lot of insights into what, how to bring a nascent technology from inception to impact. But in the course of my work at Cloudera, I naturally gravitated towards integration and access projects. Hive, for example, Scoop and Flume and Hue. Anything that allowed people to access this infrastructure, specifically working around data. was something that I naturally gravitated towards. I had another bone in my body that helped, which was I was deeply empathetic to customers using these projects, and I wanted to do my best to make sure that they're successful. So as a result, I did a lot of work with with our field people and the support people in the company in trying to understand how these projects were used and how they were working. But through the course of that experience, um, it became very clear to me that the data integration landscape had developed a rift. It had developed this massive shift that wasn't and could not be addressed by the old school vendors. And by that shift, what I mean is it was at the highest level, you could just simply describe it as the presence or the growth of unstructured, semi-structured data that was schema on read. That was not how ETL worked. ETL was structure to structure, model to model transform. ETL was not designed for dealing with things that you would interpret at the time of reading. So that was the gap that was emerging in the market. And it was very clear to me, having worked on Scoop and Flume, Scoop worked more on the structured side and from structured to semi-structured. Flume was completely unstructured. And people would overlay structure on top of it. It was primarily for log ingestion. But then the amount of things people were doing with logs, sessionization was a key use case that was driving personalizations across massive web properties, working on top of Cloudera infrastructure. So there was a lot of things that were remarkably going on in that regard because that I was exposed to through the course of working on these projects and helping customers adopt these projects. But it was also very clear to me that the ETL technology just could not deliver to that. So that was, sort of the motivation. That was the gap that I identified, and I became more and more passionate and fixated on how do we solve for that. So when I left Cloudera, I really wanted to give it a good shot, and I sat down with my wife and she worked at Cloudera as well at that time, for what it's worth. And we both sat down and we did our math and we decided, we can afford to have 6 months of me not having a paycheck. So I started reaching out to my network and I started talking to people and I had gotten connected with Girish, who later became my co-founder at StreamSets. And he had actually pseudo retired from Informatica. He was the chief product officer at Informatica. And I told him, hey, great, Informatica did a lot of good things in the last decade, but things are shifting. It requires a fresh take on, how data integration needs to be done. And, he humored me. He spent a lot of time with me. And, eventually even I felt that he understood the challenge and the gap in the market that was emerging. At that point in time, he was like, okay, listen, I'm going to write you this big fat check so you can go solve for it. I'm like, that's not the point. The point was to get you to be my partner. And so he was my first hire, actually. I'm very proud of that because his presence was absolutely meaningful because I had, even though I had, ideas about how to build and run, the business side of things, of course, I did not have that level of expertise and experience that I could have done it right. So having Girish by my side was fantastic. And, we had a 10-year run at StreamSets, and I think we did all right.
Yeah, I'd have to say you did. So it got sold to Software AG and then again to IBM.
Yeah.
Well, let's talk about your new business. And to do that, we will switch over to the whiteboard. So let's start out by talking about what exactly is Tabsdata.
So Tabsdata is effectively a pub sub model layered on top of structured data sets to enable data sharing and data access across the enterprise. There are different aspects of it that I can go into greater detail in, but at the highest level, it's an alternative to data pipelining systems. Data pipelining systems are pipelines that move raw data from one place to another, typically used for data warehousing or building data lakes and hydrating data lakes, etc. You could achieve the same with PubSub for tables, but in a meaningfully different sort of quality and different sort of quality of service semantics completely. And I'll elaborate more on that.
Yeah, so would you mind whiteboarding it out so that we can kind of visualize this?
Okay, let's see. So let's say you have some kind of a data source. Where's my pen? All right. So let's say you have some kind of data source, flat files, databases, etc., that are sitting in and this is our. Let's reduce the size of my line. This is my data source. And that's actually used and operated by some kind of like some business line of business or domain teams, if you will, right? They are running their applications. Some of them could be cloud applications and such. That seems like a rock application, but I meant a cloud. On the other end, you have your the data warehouses, the big analytic systems and data lakes and such that are happening here. So you have analytics, data lakes, etc. So the idea is that you have these source systems that need somehow to provide this data that they're generating and managing over into these warehouses, for analytics and such. And the the typical way of doing this through pipelines is you'd have a pipeline being built that does some kind of uh, transformations, format conversions, and so on and so forth, does a whole bunch of other things on top of it, and then eventually deposits it into your destination system, your data lake or data warehouse, etc. Optionally, it can actually also do things like sending information to some kind of a catalog service, such as Iceberg or third-party catalog system, Atlan or what Calibra, whatever be the deployed catalog in the system. Now, this model is what I call, it's effectively dump raw data and figure it out later model. And I say this because over the course of the 10 years of building and deploying and sending customers in that pursuit of managing their centralized analytics and such using pipelines, I feel like I'm also to blame for like this mindset that takes shape here, that actually emerges, which is these pipelines are capturing absolutely raw information. So So it's the raw data that gets lifted from the source systems and deposited over in the destination systems. And consequently, you would see things like vendors, evangelizing architectures like Medallion architectures or the Mart architecture, where you go from what could be like the bronze layer to silver layer to gold layer. And the idea is, this is your raw, this is somewhat kind of sanitized, and this is ready to use data. And you're going through these transformations and processing and selecting and filtering data, and discarding unnecessary data, in order to be able to get to the point where this data is consumption ready. Right? So this process is an onerous process. It is done by data teams. And these data teams effectively are the ones that are sifting through tons and tons of raw data information only to identify what exactly is of use of how to recreate the reality of the source system in a manner that is usable for analytics consumption purposes. So just take a real example. Let's take a real example to hone that in. If I were to draw a pipeline from a Salesforce instance into my Snowflake or into my data lake on Databricks, it's very likely that that pipeline will basically deposit a ton of attributes that are coming from the objects that are there in Salesforce that are being captured by the pipeline. So if let's say you want from an analytics perspective, you want to be able to tell the forecast that your sales team is sharing on a weekly basis. Just that question of what is the forecast can be easily answered if you have the person who's running Salesforce do the forecast report, externalize it into an Excel file, and send it to you. Of course, that only works when the systems are small and there are not too many people involved. But the moment you're dealing with a large enterprise, that's not a scalable solution. That's not a usable, sustainable solution. So what you do is you end up building a pipeline that is reading a bunch of objects that will together be joined and somehow transformed into creating the forecast output on the analytics side. But these objects have tons of attributes. They have tons of things that are absolutely not relevant to the forecast. So then the question becomes, what do you do with all of that extra data? And how does one take that extra data and then figure out what's of value and what's not of value, and then bring it back into the notion of what the forecast reality is? And this is that, let's dump and analyze later kind of mindset that pipelines bring. Because what it does is it takes the data teams for granted. And they're the ones who are dealing with quality issues, they're dealing with consistency issues, schema validation issues, and so on and so forth. They don't even have a view of what the business process in the sales team is. So for example, over the course of StreamSets, I saw my sales team change the qualification process so many times, change the lead progression, the opportunity progression process so many times, because they were fine-tuning it to the specific set of opportunities that they're going after. And when those things happen, some of those attributes change. A very simple example, if I have a lead state, that I started out with, working, not working, qualified, disqualified, blah, blah, blah. But then I later add another, flag to it, another lead state to it in that state machine of leads. That may or may not show up in my analytics, that may or may not be even relevant for my analytics. Because if my analytic is only dealing with, what is MQL, that is ready to turn into SQL, I may not care about anything that is pre-MQL attribution. So there are a lot of these things that the data team is burdened with without knowing or owning the business aspects of what that domain team is doing on the data source side. So this model is rife with those kind of pain points. What Tabsdata is doing, it's imagining a different reality, which is, hey, instead of, let's move this up. So instead of having, these pipelines that are effectively just dumping raw data, you can take your, let's call it the Salesforce system. You can take the Salesforce system and then publish your forecast table. And this is done, by your ops engineers either who are working as part of the sales team or they're part of the data team that are loaned to the sales guys. But the point really is you're not building a pipeline that just takes a whole bunch of exhaust information and random attributes that are absolutely not relevant to downstream consumption, because what downstream consumers want is the forecast. Who's better to give you that very specific detail than the domain itself, right? The sales guys themselves. So they give you this table of a forecast that they publish on a set schedule. Say maybe they're publishing it, weekly, daily, monthly, whatever is your cadence. And you can then have subscribers that can then deposit it into your S3 object store. And they can also have this table automatically update your I don't know, Athena iceberg. Sorry, I need the eraser quick. So your iceberg catalog. So you can have, that same publisher not just move the data into the S3 bucket of choice, but also update your central catalog. Now, there are a few right out the gate advantages that you get out of this model. One is the fact that your data team is getting ready to use data sets. It's not having to sift through tons of vague and meaningless information that is of absolutely no consequence to them to sift through and figure out what exactly is of purpose and how to use it. And it's a whole nother ballgame if you say like, listen, I want my data lake to be storing all aspects of raw data. That's a perfectly legitimate use case, and that needs to be done in a different way. You don't want to be using the same vehicles and mechanisms that you're using for empowering your analytics and your central kind of decision-making capabilities. You don't want to be overlapping those requirements that are fundamentally at odds with each other, by using the same mechanism. So effectively, what Tabsdata does, this pub sub for tables as we call it, it's enabling your data producers to publish and data consumer to subscribe structured data sets that are ready to use. And these structured data sets are effectively of high quality. They represent something that the rest of the organization needs from that consuming the data production domain or data team, sort of the teams that own the data source, that is. So you effectively shift the burden of quality and accountability to the left, towards those data source owners, which is the absolute right things. Now, if you think about it, from an industry perspective, this has already happened in other disciplines, and it's widely regarded as a success story. That is, for example, DevOps. The idea that CI/CD is part of an engineering workflow, was not the way when things were in the waterfall model. And in the waterfall model, when you'd had hierarchical sort of distribution of requirements that get forever to be translated into actual implementation, they'll then jump through like a testing and a quality gate to be able to release, etc. Those models don't work because they put tremendous amount of pressure on sort of the downstream teams to be able to make sure that they can justifiably catch things in a manner that is beyond their control, given the size of the components, given the complexity of the components. Data teams are no different. When they're dealing with tons and tons of raw data and somebody comes in and says, hey, we'll wave a magic wand and go from bronze to silver to gold, you have to also understand that by not having this mindset of what is needed, why is it needed, you're not empowering your domain teams to participate in your data strategy. So this shift left that happens naturally as a way of pub sub for tables is a meaningful thing from a enterprise perspective that should allow you to take better advantage of your organization's resource and capabilities. This is way more sustainable than having large data teams that are sifting through a ton of noise and then keeping up with firefighting as things change, which they inevitably will, because the business processes on the domain side will continue to shift and evolve in order for them to be doing their job effectively. So anyway, sorry about the little bit of a ramble. Happy to dive into more details in any of these aspects.
Yes. So I completely agree. Well, first off, you have some of the best handwriting of guests on the show, so this is actually legible, which is quite nice. But I completely agree with you on the shift left here. We're seeing that, and this is always has been my definition of data product. Of the data product that you're exposing here is not this person's responsibility. It's not subscribers' responsibility. It's the producer's responsibility here. But as I'm watching this, I'm thinking, okay, well, why wouldn't I just do this already with the pub sub I have of choice I have? Like, let's say I have Kafka Pulsar, I could just publish this on some frequency, and there I'm done. What special sauce are you doing here?
That's a fantastic question. So let's take a closer look. If I have a Kafka, um, and I have a publisher, and that publisher is basically sending me events, and then I have consumer 1, consumer 2, consumer 3. So I have multiple consumers that are on the other side of this Kafka, or it could be Pulsar, or it could be, of course, data integration hub from Informatica, or it could be something else, like any pub subsystem. But what effectively is going on here is that these things that are being sent over to this infrastructure are basically single payloads, single envelopes that carry some payload. Now, you could set up a schema registry that says, this is X and, this is X and this is Y and this is Z, etc. But the fact of the matter is, that's a protocol that is implicit between these producers and these consumers. This is an implicit agreement. What happens with implicit agreements is they cannot be codified. They cannot be done, implemented in a manner that can be validated and tested. It is an agreement. It's a handshake between the producer and the consumer. Plus, the fact is that because these are singular events, or they're a stream of events, you end up having to rebuild the entire context of these events. You rebuild the entire aspect of what these events are. So, for instance, if I am sending events, as a publisher into my messaging system, and these events have to do with, let's say, a ticker symbol. So I'm saying, hey, now the sticker is at this, this price. Now it's at this price. Now it's that price. There's an obvious, internal implied agreement, a context that the consumers will have. They will need to fundamentally understand this is a ticker symbol, and it actually represents X, and every update represents data that has changed in the last 30 milliseconds or 100 milliseconds, and so on and so forth, right? So now you have that notion of the quality of service, how that context is, and so on and so forth, and then on top of it, it'll also have the ability to tell, oh, this ticker symbol payload was for this particular date and this particular time. And so they'll be able to bucket it into, daily kind of movement and where did it start, where did it end, how did it start below, and so on and so forth. So there's a lot going on in terms of implied contracts between these systems. And this is how event architectures work. This is how, applications integrate. But what we're talking about is data integration. And data integration is typically between passive systems. Data integration is where data is sitting at rest in the source, and it is going to be sitting at rest in the destination. And then there are actors that are using or creating data at the source, and there are actors that are consuming data at the destination. So the context, there is no implied agreement in data integration world between the data producer and the data consumer, except for the fact that they just happen to be interested in the same data. That's about it. So the data has to be, built with the context, and it needs to be delivered with the context alongside. And there need not be any implied agreements, of course, outside of super high level enterprise wide, things that are taken for granted. Outside of that, there need not be any point of implied or explicit protocol between these systems. They're fundamentally decoupled systems. Your analytics that is happening on the right is fundamentally different from the domain team's business case execution that they are, pursuing on the left. That's not going to be the case if you were to be saying, let me just send my every record as an event. You will invariably end up needing a lot of implied agreements and contracts on the either side. So that's what separates application integration from data integration. One is based on passive systems that carry the context with themselves. The others are active systems that actually create protocols, sometimes implied. Most of the times I would say implied, and very rarely explicit, but not fully enforceable by the systems in between.
So let's say I'm an architect and I'm sitting here listening to this and I think, okay, I get your implicit and my implicit agreements aren't that bad. What I will do is I will send this table as an ACID transaction, as a transaction, so that theoretically everything gets produced at the same time and gets consumed at the same time over here. What's wrong with that naive approach?
Well, you know, at the very get-go, you have to ask yourself, are these systems optimized for large data sets? How big is your table? Are you going to be doing a good job of is your system going to be capable of solving for this? For example, I remember that in some infrastructure, and I'm not going to name the names to protect the guilty, you have to allocate space based on the size that you're expecting. And the moment you go beyond that size, you get truncation and all sorts of bad things start to happen. Well, those kind of issues can easily come in the way of actually you physically implementing a solution like that. Now assuming that you're somehow able to overcome this and your sizes are somehow capable of being sent across through sort of a messaging infrastructure, you would then run the problem of the semantic of what exactly that message is, what exactly that table is. I'm publishing an entire table. So am I every particular table version, every particular table that I publish right now, followed by, a minute later, does it replace that entire data set? Is it appending to that data set? So you again go back into this mode of figuring out what exactly is your protocol between the two. And I would even argue that while you may be able to do it, you would very quickly run into the problem where you want a second order derivative of multiple of these published tables. So one thing that I did not show here, but let's see if I can use a different color of pen to show you. But basically, if I can take this forecast table along with some other table that is published, let's say this is my finance table. I can take these and create derivative tables that can then also be subscribed to in in the consuming system, in the data lake. But the point is,
well, let's pause there, because what you describe is actually, unless people have tried to do this, this is always the Achilles heel of these systems. Is you have a person who's responsible, or a team who's responsible for this, and you have a team who's responsible for this. But that very rarely exists. It's rare that you just have this table that exists in a vacuum, and this table, there's almost always some sort of join, and who's responsible for that join, and who deals with the quality issues. And if you have a good way of creating this and materializing this, then you have much less friction of creating these derivative data products, and you inevitably will create derivative data products.
Absolutely, because what gets published directly by the domain teams, assuming they can publish these tables, those fundamentally become your data contracts. These are the things that they're responsible for, sharing with the rest of the organization. And these data contracts, you can think of them as fundamental building blocks. There is, there's this idea that a domain team will continue to change and evolve as it needs to in order to stay relevant and productive and meaningful, and so on and so forth. But they do so, in a sort of a pseudo autonomous way, where their core directive is aligned with the broader enterprise's directive, but at the same time they have a lot of leverage and freedom to be able to execute that core directive in a way that applies to their specific line of business. In doing so, they may adopt new technologies. In doing so, they may adopt new systems and new designs, and so on and so forth. But whatever they do, what they're basically responsible for, sales in this case, in this example, will not fundamentally change. Their domain goal will not change. And that contract represents the data, incarnation of that goal. Like, how are they doing? What have they done, or how they predict to be doing, so on and so forth. So that becomes a data contract. And having somebody read raw data from a ton of systems that they're engaging with, and then recreate that reality of how they're doing, far cry from them telling the rest of the organization that's how they're doing. So that becomes the building block of what exactly they're responsible for. And then you have these building blocks, you can easily create derivative products, assuming that those building blocks are of high quality and you have clear accountability. Because if you have clear accountability of those building blocks, then by definition, you have clear accountability of the derivative products. Because you would know with provenance exactly what is coming from where, and you'd be able to trace it back to the roots of where exactly any issue may have seeped into your system.
So as we double click into the pub sub system itself, are you writing that pub sub system? Are you writing this container around it? Are you using an existing pub sub system?
So we actually built it, in it's open source. It's on our GitHub, and github.com/Tabsdata. It's a server infrastructure. Surprise. The server infrastructure that allows you to publish large data sets, and subscribe to those large data sets. So let me give a schematic of how it looks like. You have, let's call it, so this is our Tabsdata system. You basically have producers that are publishing tables in this system. And these tables effectively are data sets that are sent by, oops, so these are basically publisher functions. And these publisher functions are effectively Python functions, that you define that take in a data frame or one or more data frame, and they produce, output data frames. So this data frame actually represents whatever the outside source is. This could be, your Salesforce system. It could be, a database like a Postgres or a MySQL. It could be files sitting in a directory that have to be read periodically and so on and so forth. It could be log files that are being, rotated by your logging system and so on and so forth. But it could be any data source that effectively gets mapped to a data frame. The arrow should probably point this way. So this gets mapped to a data frame. The data frame is passed on to a publisher function, which is written in Python. And your publisher function effectively then goes through that data frame and then creates an output data frame. And this output data frame then gets mapped to a table. So let me pause there. This is just the mechanics of publishing a table. This connectivity to the external data source and mapping into the data frame is done by Tabsdata transparently. You don't have to worry about it. So whether it's an external database, whether it is, a file system access, or whether it is a SaaS system like Salesforce, that is a connector that you use in your publisher functions declaratively. And when your publisher function is invoked, your input data frames, quick side note there, we call it table frames for a different reason. They're not like, they're exactly as good as data frames, but we call them table frames because they have provenance information for the table within them. And that's a different conversation we can go into later. But the idea is this publisher function is getting input data frames and it's producing output data frames. Input data frames are mapped to external sources. Output data frames are mapped to tables. Let me pause there and see whether that makes sense.
That makes sense. Now show me the consumer side, because I'm curious how you're going to handle the memory limitations on the consumer side, as well as, I would say, bandwidth limitations.
Right. So some of that, is contextually relevant to different kind of external systems that we have to deal with. And, we have a handful of systems that we deal with on the subscription side. But let me start with the very basics. And the very basics is that, you have tables sitting in the system that need to be mapped to, your external, database, for example. So you would effectively write a subscriber function. And what the subscriber function will do is it'll have a data frame.
And to be clear, that the subscriber function is running on the cluster, not on the actual consumer.
Correct.
Okay.
It's part of Tabsdata. So this subscriber data frame is mapped from internal table. And then this will produce a data frame that gets mapped to the external system. This part is handled by, this mapping to external system is handled by Tabsdata. Your subscriber function is a vanilla Python function that takes an input data frame, produces output data frames without knowing where the input is coming from, where the output is going. The connectivity, the materialization of the data frame is handled by Tabsdata. So the input data frames in case of subscriber is coming from an internal table that is managed by Tabsdata. The output data frame is transparently sent to the external system. Now, to your question, how do we take care of sort of the constraints, the physical constraints that may be relevant? And the answer is it depends upon, from connector to connector. So for example, there are connectors that are writing to databases and they will do a batch job of shifting multiple things. Instead of having one large update, they may actually do smaller updates on temporary tables and then move them directly into, a singular table. There are other scenarios, for example, where the it's a two-step process. It's the process of getting the data and then updating the catalog, as is the case with Iceberg, where you can publish things on the object store, which is the actual physical store for the data, and then update the catalog in an atomic transaction that points it to the new location. So there are different connectors, destination connectors will handle that differently. And then you have some control over like how you can tune it for optimal performance. Of course, we want to make sure that you are dealing with as much configurability and serviceability of the system. So we will be, we are constantly adding more configurations and exposing that. But then, of course, we don't want to overcomplicate things by making sure that they are, like giving you way more control than maybe necessary. So we want to address the 80% path. Well, for the 20%, we want to give you the knobs and dials.
Makes sense. And so on the database side or on the consumer side, we're dealing with Python as well for the data frame.
Yeah. So this is the subscriber function is a Python function.
Okay.
Now, the only thing that is not missing, but it is probably obvious here, is the fact that you can have, let's see, we already used this color. You already have, these tables inside the system. So you can actually create a transformation function that takes in a data frame and produces a data frame. It's again written in Python. So there are these three types of functions. You have a publisher function, you have a subscriber function, you have a transformer function. So you create these functions and you register them. And these functions indicate through declarative descriptors, they indicate which data sources they bind to, which data source, destinations they output to. In case of publisher, the data source is external to Tabsdata, the destination is internal to Tabsdata. In case of a transformer, the source is internal to Tabsdata, the destination is internal to Tabsdata. In case of a subscriber, the source is internal, the destination is external. But the idea really is you're binding them across names and collections in a manner that allows you to later go in and say, hey, I'm a new publisher or I'm a new subscriber, I'm interested in that table. And the system will automatically give you access to that table. So every single time, let's say in this particular example, this is a very trivial example, but every single time the publisher runs, some data gets published, what will happen is this table will go into the, next revision. The head of the table will move. A new version of that table will be created. That will trigger automatic invocation of any downstream dependencies. So in this particular case, it will be this transformer. And when this transformer runs, this table will change version. The head will move. And when that happens, the subscriber will be invoked and the subscriber will deliver that data set to the destination. So the thing that I sneakily introduced here is the versioning of these data sets, but that's fundamental to making sure that you have clarity and consistency across what's happening through this distribution mechanism, this integration mechanism. Every table is basically one table that is versioned, and you have access to the older versions. This transformer, for example, can access one very common use case that we see is the transformer function accessing the published tables and in the current state and the previous state, and then creating a CDC feed on top of it just by comparing those two sets. So you can do set comparison between what is head and what is head minus one, and then create a CDC feed so that your destination system, if it is a system like a search index, like an elastic search index that supports upsearch, you don't have to go tear down and rebuild the index. You can just very target, in a targeted manner, we can go change the very specific attributes that need to be updated in that index. I'm sorry, Jesse, I threw a lot of concepts in there, but I'm happy to slow down.
No, it makes sense. And since this is unapologetically technical, you are forbidden from apologizing for going into any technical depth. Absolutely forbidden. So what I find interesting here is this is actually an idea I had quite a while ago of how data should be done, and what we're seeing is in most systems right now we'd have a little thing off to the side here where it's Flink or it's something else. If you're doing Kafka streams, it's
Right.
there's a Kafka streams over here that's receiving this and then sending it on, and or Flink or what have you. When you ideally want this to be part of a holistic system, if you could make this part of a holistic system, then you reduce some of the complexity on this side, some of the complexity on this side, and you don't have to add something over here. And is that a good summation there, Arvind?
Oh, it's fantastic. If I may take it one step further, any stream processing that you do is operating on the concept of a stream. A stream is basically an unbounded data set of sequentially ordered events. That's what a stream is. It has a semantic. It is not quite the same as a data set that is ready for consuming. In order to turn a stream into a ready to consume data set, you still have to apply some logic, and you need to have some implicit protocols to turn that stream into something that is consumable. And it may not lend itself into all sorts of use cases, primarily because it's more suitable for stream processing use cases, a whole nother class of use cases that exists out there in the wild. So in stream processing, you have the notion of continuous queries. You have a notion of rolling windows, sliding windows, and so on and so forth, which do not make sense from a non-stream processing use case, which is typically what data integration is about. So this model is actually not based on streams at all. This is actual data sets that get updated atomically. And when the updates happen, the new versions are propagated through the dependency graph of tables that are interlinked, eventually falling into the next into sort of the next zone of whatever you are working with in your destination systems. The fundamental difference outside of this being fully formed, contextually complete data sets that are ready to use as compared to streams, the other thing that is at play here is the idea that this model is declarative. It is not an imperative model. So take a moment to appreciate it, because if we go back, what's a simple example? Oh, a very simple example is the build systems that we've kind of evolved over the course of last many years. Remember the popularity of Ant?
Yeah.
And with this, you have build.xml file where you basically go code very complicated build steps. Sometimes you create your own Ant tasks and so on and so forth. And the idea really is that you would be able to do very targeted, very purposeful builds as long as you understand the system. The downside is if you build that build system, it's going to be near impossible for me to maintain it. Why? Because you are you, I'm me, and that system does not lend itself to being very easily understood. That is the parallel between the parallel between that and data world is pipelines. Pipelines today are basically one-off data engineering efforts that somebody glues together, where they're taking system data from some source system, doing some custom transformations on it, and then sending it on destination systems, maybe in multi-step way. They're changing formats, doing this conversion, that conversion. And it's an imperative system. It's a programmatic system that you are programming over the course of like multiple hops, multiple tasks in a, what gets turned into a DAG, then gets executed by an orchestration system. It's a complicated system. No wonder, at least my experience is when people have more than a handful of pipelines, things get so complicated that they don't want to touch it. They don't want to disturb that system. And the overreaching part of that is Sometimes not disturbing the system actually trickles back to the data sources themselves, where they're telling the domain team saying, stop making changes, guys. Or if you want to make a change, you have to follow this really heavy-handed review process, change control process for something that may not be even relevant to that company. It may be only relevant to the execution of the domain team. Now, and eventually got replaced by Maven and Gradle and all these declarative systems. And the beauty of these declarative systems was you don't have to understand what I'm thinking. The project object model will tell you exactly how the build will work. So there is no longer, having to, do a science project to understand and debug a build. The builds are simple, they're declarative. These plugins will bind to the lifecycle phases and they'll execute. That's it. No wonder these Mavens and Gradles, they became so popular. They took away so much of that complexity away. That's the beauty, of a declarative system as compared to an imperative system. This Tabsdata is a declarative system as compared to data pipelines. You declare your producers, you declare your transformers, you declare your consumers. That's it. The system figures things out together. It binds to, if I may extend and use that same language as Maven, is like it binds to the lifecycle phases of data movement and does the right thing. So, for example, here's a simple example where it may not be as simple to do it yourself as you may think it is. Let's say you have you have a table A, and you have two derivative tables. Table B and table C. And then you have a third generation derivative table called table D. So this is an external publishing workload. This is an external subscription workload. These are internal transformations. So let's say they start out, this world begins with everybody at version 1. This means that this table just got published, it has version 1. Because of the transformers registered on this table, they created version 1 of B and version 1 of C. Because of the transformer registered on this subscribe, the table D side, that got triggered and it took version 1 of table B and version 1 of table C and created table D. Now let's say at some point in time there is another push of the publishing table, and it goes from version 1 to version 2. And this will automatically trigger the refreshes of these tables. But what happens if this gets done in 1 second and this is taking 60 seconds? You could end up in a situation where the transformer that is acting over here is seeing B version 2 and C version 1. This is fundamentally an inconsistent state of the world. That inconsistent state because there is no true world in which this transformation would make sense if one of its inputs is seeing a new version of reality than the other input, right? So this is equivalent to what in C++ they call the diamond of death problem. But you get the idea. This could, there could be a whole bunch of these kind of dependencies in the system that require you to have a galactic upgrade, saying, hey, do everything, run all the pipelines until you're done, making all the changes. And that's a sort of pseudo deterministic at best kind of a mechanism, and it's extremely wasteful, extremely complicated, and something goes wrong, nobody's there to help you but your printlns and system logs that are going to be near impossible to follow. So what Tabsdata does is it will basically not invoke this world ever. It will targetedly wait for invoking this transformer only when all the source tables are in a consistent view of the world. So this is equivalent to, in a database, what is read committed transaction isolation level, but it is happening with distributed tables that are potentially running in different locations, on the system.
And that is the special sauce of this. That is where that's where you're thinking. Although Arvind said that explain this, doing this yourself is really difficult. And those who watching this are thinking, I would rather have somebody else do this, and they should be.
Yeah.
You don't want to be writing that code yourself. That's a difficult process.
Absolutely. I hang out in so many of these data engineering communities. I'm mostly a lurker, but I constantly hear people saying, "Hey, I've got so many of these dependencies. I don't really know how to sort them out." And it's not a trivial problem. Even if you knew how to sort them out, the correctness needs to be mathematically provable. Otherwise, it doesn't count. When you're dealing with data, Jesse, this is something I've learned over the last 2 decades. There are 2 cardinal sins: data loss and data corruption. You do that, you've kind of failed the people who work with you. And so every data system has to go out of its way to manage the correctness and consistency. And in a world like this, where you have all these intermittent dependencies, uh, I've seen people do brute force. I'm going to upgrade everything all the time. And that's so wasteful, and it's so painful, and it's so slow, and it is so time consuming and costly. It's absolutely not necessary. So yeah, this is one of the secret sauces why you should use Tabsdata, because you will never know all of these things happening under the hood, but they'll guarantee the correctness and consistency of your data.
Excellent. Well, let's go back and I'll ask you one final question if you'll stop sharing.
Okay. Yep.
So I forgot to say when we were talking about the early days of Cloudera, I hope that a lot of Clouderans watch this, and if you do, say hi. I haven't seen a lot of you in a while, and I miss you all, and I think we both have really fond memories of that. And part of this is that you co-founded Tabsdata with Alejandro Abelnur, who was at Cloudera, who I knew at Cloudera as well, and then you worked with him at StreamSets. And I noticed as a lot of your founding engineers are from StreamSets. How did you create a company where people actually wanted you to follow you to that new thing?
So I think I'm tremendously lucky to be surrounded by people who have still want to work with me. So I think that's fantastic. But let me give a little bit of closer look into my co-founder Alejandro. Jesse, his name is Tuku because he's from Tucumán. That's why we call him. So the Tuku and I actually worked together back in Sun. When I was going through what I previously described as only Silicon Valley nonsense, he also found himself in Sun, and we together landed in the market maker group. And that was the first time I worked with him. And then, he moved towards the portal server. I moved towards the security server. They were both working on top of directory server, and we were very, we were close in coordination with each other. We used to sit, very, very close by in the same campus. Then when I went to Informatica, Tuku went to Yahoo, I believe. And he's got a little bit of like traveling the world kind of bug, because he stayed in different parts of the world. He stayed in India for 3 years, and he had a 2-wheeler in Bangalore. He would make rotis and such. And then he did from India. He moved to Singapore. He stayed in Singapore for a while. So when I joined Cloudera, one of the things that I was asked to do was to pull in an orchestration engine into the CDH distribution. So after looking at all the different options, we decided Oozie was the right thing to pull in. Oozie it came out of Yahoo, and guess who wrote it? It was Tuku. And as I was like pulling in that system and making it compile against CDH and working through all the nuances and details that were breaking down, I was like, found myself thinking like, man, this piece of crap software, like I wish I could pull Tuku in and have him maintain it. So I actually picked up the phone and I called Tuku and it's like, you know what they're making me do? They're making me pull Oozie in, and I hate it. Why don't you come join Cloudera and you can do it yourself? And he did. So he actually came to Cloudera based on my nudging of him. And then when I started StreamSets, I found myself meeting Tuku after one of the meetups that we had here in Mountain View, I think somewhere in Moffett Field, where he was talking about some resource management implementation that he was working on at that point in time in Cloudera. And he's like, hey, listen, I think I'm like starting to think about the next steps, and I really would love to join you. So he was the first guy, he was the first engineer to be hired in StreamSets. So we go a long way back, and somehow we have managed to grow more and more fonder of each other, and really appreciated how complementary the partnership has been over the period of time. So definitely it's my privilege that he ended up after I left StreamSets and he left StreamSets, Software AG, that is. He reached out and we were hanging out, and he basically said, there were a lot of lessons learned. Do we want to go give it one more shot to make it, to at least try and do it right, better than what we did the last time? And both of us definitely have at least one more in us to sort of go at. So I was on board, and he was on board, and it was beautiful because it's not like I'm telling him something to do that he doesn't fully understand, or he's telling me something to do that I don't fully understand. This is a shared idea. This is 100% both of us in it. So remarkable. That kind of founding mind meld doesn't quite always happen. It's almost one person selling. Like in case of StreamSets, I was the one selling to Girish all the time. And of course, once the business takes off, then there's a whole bunch of other things. So yeah, definitely feel extremely lucky and privileged to have Tuku by my side. You asked a very important question, which is, how do people follow? Like, how do you create a company where people follow? And I don't really know the true answer. I'll tell you what I think is the reason. One of the things that we did very well at StreamSets, and I think I did a little bit of at Cloudera, was have an understanding and appreciation of the fact that it's not the technology or the ideas that make companies successful, it's the people. So if you can help get the people that you're responsible for that sense of ownership and care that they truly deserve, then you don't have to care about the company, because all of your team will care about the company. It's you take care of the people and the people take care of the company. That's the mechanism, in my opinion. That's how it works. That's how it should work. Now, of course, that's easier said than done, because there's so many things, people often land into roles that they're not good fit for, that people land into challenges that they feel, they were ambitious about, but, something changed, and or that no longer kind of fits with. So you have to course correct and manage things in a respectful and caring manner, because, this is where I feel like that fundamental principle that do unto others how you'd want to be done unto you, kind of bears 100% applicability. Because if you're treating your team like you'll be treating yourself, there will be a bond that'll outlast that engagement. And so when I started StreamSets, a whole bunch of people from who were part of my team in Cloudera, they came over. I have that privilege again. When we started, we didn't have any money, and we had the engineering team raise their hand saying, "Yeah, we're ready to jump in." So it's amazing, when you take care of each other and you're true to each other in terms of. I'm sorry, it's sounding pretty melodramatic. That's not the intent, but we after all, we're adults. We all have our life challenges. We all have our families to take care of. We all have our own quote unquote fiduciary responsibilities to our households, to our families, to our kids. Those are the primary concerns that drive all of us. And then there is work. And that work is where you're spending a majority of your waking hours. If it is not a fulfilling experience, that's kind of a sad thing, sad outcome to be dealing with, right? So my pursuit, ever since I became a responsible adult, which I think like probably around the time I joined Cloudera, was just, to appreciate the fact that there's so many brilliant people with such high potential that we get, the privilege of working with. My role as an enabler is to just take the roadblocks out of their way and open the gates for them and let them achieve their potential. And when they cannot, it's not that somebody is smarter and somebody is not. It is because it's a complex trajectory of multiple things happening together, and not everything will work as expected. And that's okay. There's almost always there's a meaningful way of dealing with those situations. That is respectful, that is credible, that is, something that you would do for yourself. And, you follow that implementation philosophy, I guess, people want to be with you. Like that's my thinking. And again, I'll add one last thing, Jesse. I can wax poetic about philosophies of building companies. None of it means anything because no one person can do it. You have to do it with your team. Your team has to buy into this idea. Your management team, your on the ground, your folks in the field, everybody has to live it and breathe it and understand it. That's when the culture emerges. Culture is not the making of the founder. It's not the making of an individual. It's not the making of a CEO. Culture is what all of us do together. So we just have to remind ourselves what is important. How do we respect each other? How do we support each other? And things tend to work out.
I love it. Arvind, thank you for coming on and sharing so openly. I really appreciate it.
It's been a pleasure, Jesse. Thank you so much for your time and patience with me. And I'm sorry if I went on random rambles. But yeah, I really appreciate the opportunity for being here.